So guys, we are done with the theory of gravitation. Now it's time for us to take up a few problems. Here's the first question for you. You have to find the gravitational force of attraction on the point mass m placed at a point O by a thin rod of mass m and length L as shown in the figure. Arnav is going to explain us how to do the problem.
See, it's a very easy question to begin with. First of all, you'll have to find the elemental force. So first, let's consider this rod itself. Consider a small element having length dx, so at a distance of x from the point mass m. Okay.
Right.
So first we have to find the mass of this small element. So dm will be equivalent to m upon L, that is mass per unit length. Correct. Into dx. So this is the small elemental mass that we have got now. Now we just have to write the formula of gravitation due to this small element. So that will be equivalent to, let's write df as the small unit of force, will be equivalent to mass m small m upon L into dx upon x square, where x is the distance, so upon x square, and g, the gravitational force constant, will also come here. So now while integrating the whole thing, we'll integrate it from d to d plus L, and all the constants will come out into g upon L dx upon x square.
Correct.
So while integrating it and putting the values of the constants over here, I'll directly write it down. It will come out to be 1 upon d minus 1 upon L plus d.
Correct.
So this is equivalent to the force. So the final answer will be equal to g capital M small m upon L into L upon d into L plus d. So this will cancel out. So this is the solution, this is the answer of it. Now we have to see one small thing, that when we are writing down the force, so we are treating this as a small element because in the question it is written that it's a very thin rod. So that's why we are treating dx also as a point. Otherwise this formula would not have been valid, because we are writing the formula between 2 point masses.
Correct.
So this is the solution.
Okay. Thank you, Arnav. Let's move on to the next question, guys. So we're on the second question now, which is a solid sphere of uniform density and radius 4 units is located with its center at origin O of coordinates. Now two spheres of equal radii 1 unit with their centers at A, which is minus 2, 0, 0 and B 2, 0, 0 are taken out of the solid, leaving behind cavities as shown. Now you have to select correct option from the given 4 options, and remember there can be more than one correct options. So Arnav is going to help us with the solution of the problem.
See, the first option is the first let us look at the diagram once. So this is the diagram and these are the cavities over here. Right. Now once we begin, we'll have to check out the options one by one. The first option is the gravitational force due to this object at origin is 0. Now let us consider that these cavities weren't there, okay? So what is the formula of gravitational force? The gravitational field would be g m upon r cube into r. This is when r is less than capital R, where capital R is the radius of the sphere.
Correct.
So under this case, the gravitational field would have been 0. But now because these cavities are removed, each cavity would have some effect on the point O.
Right.
So, but the effects would negate each other because this is symmetric about the YZ plane. So the amount of negative gravitational field, if I could say that, due to B would be equivalent to that of A. So both of them would cancel out and the net gravitational field would still be 0 at this point. So therefore the first option is correct. Now coming on to the second option at B. See, first of all, the point B is highly unsymmetric. So if these cavities weren't there, then obviously we would have a gravitational field. If cavities weren't present.
Correct.
If they were absent. Okay. But now due to the cavities, due to this B cavity, there won't be any change in the gravitational field because the point is at the center of the cavity B. Now the cavity A would have some negative effect on this, but this effect
would
not be
as strong as B.
Yeah, it would be very less compared to this, because first of all the mass of A cavity is 64 times less than that of the whole sphere. So this would not cancel it off. So therefore the option B is incorrect, because the gravitational field would still exist. Now the C option is the gravitational potential is same at all points on the circle y square plus z square is equal to 36. The circle will be something like this on the yz plane. So as we know, all the points on the yz plane are symmetric, like so cavities A and B are symmetric about the yz plane. So therefore any effect of A would cancel out the effect of B. So therefore the effect due to the cavities would be 0 at any plane. And another thing, this is a circle. So this is a point circle like this. So for this electric field inside the cavity, this thing, the gravitational field would be same for all the points at equal distances. So therefore the C option is also correct, and similarly the D option is also correct, because these are symmetric, so these cavities won't have an effect. Yeah, and only the bigger cavity would have an effect. So the thing that we need to remember from this question is that first of all we need to remember this formula. If you don't know this formula, then you are dead. And the second thing is cavities. So try to look for symmetries in cavities and in questions such as these.
Okay. Thanks, Arnav. Let's look at the third question now. Guys, the third question for us is, there are three particles each of mass m. They are situated at the vertices of an equilateral triangle of side length A. The only forces acting in this case are their mutual gravitation. It is desired that each particle moves in a circle while maintaining their original separation A. Find the initial velocity that should be given to each particle and also the time period of their circular motion. Arnav?
See, first of all, the first step in this question would be to draw the diagram, obviously. So I'll begin by drawing the diagram. This is an equilateral triangle. There are 3 point masses at the ends of it. Let us name it P, Q and R. So, and the lengths are A. All 3 of them are A. So this length would be equal to A sine 60 degree.
Correct.
Because this angle is 60 degree. Like all 3 of them are 60 degree. So this would come out to be root 3 A upon 2. Now, first of all, we'll have to find the center of mass of this thing. So everyone knows that the center of mass of an equilateral triangle in this case would be at the median. Right. So the particles would rotate about the center of mass. Like if we put in the equations of uniform circular motion and all, so we have to consider this point as the center. So for this, we'll have to find this length. So this length, let me call it L. So L would be 2 upon 3 into root 3 upon 2a. This is the length of the median, and this will be 2 upon 3 times of it, because this point divides the median in 3 equal parts. Correct. So this would come out to be a upon root 3. Fine. So now we have got the information about the radius of the circular motion, and we also know about the masses. Now the next thing that we have to do is we have to find the force acting on each particle. Right. So let us consider a point R. This mass is m. So there will be 2 forces acting on it. One would be F1, the other one would be F2, and these would be the angles. So we have to find the net force acting on it. So we know that F1 is equivalent to gm square upon a square. I'll directly write it down. Right. And F2 would also be equivalent to this only, because the distances are same and the masses are also same. So now we'll have to find the component of this. So that would come out to be 2 into F1 into cos 30 degree. This is the angle 30 degree, and there will be 2 forces acting on it. So this would be equivalent to 2 into gm square upon a square into cos 30 degree, which is equivalent to root 3 upon 2. Right. So root 3 gm square upon a square. You can see that the perpendicular ones would cancel off. So hence the net force on this particle would be F net equivalent to root 3 g m square upon a square, and the radius of the circular motion would be a upon root 3. So now it becomes very easy, just another problem that this point, there's a circular motion happening, so we'll plug in the equations of the circular motion. The force should be equivalent to mv square upon r. So the force is this much and the radius is this, so I'll just plug it in. So root 3 g m square upon a square should be equivalent to m into v square upon r. R is equal to a upon root 3. So all these things would cancel out, and the velocity would come out to be under root gm upon a. See, this
Right.
mass will cancel out and you can like simplify it. So now that we have the velocity, the first part of the question is over. That is, we have to find the velocity for the time period. Just divided over here. Yeah, time period is equivalent to 2 pi upon omega, where omega is the angular velocity.
Correct.
So omega can also be written as 2 pi v into r. V upon r is equal to omega. So I'll just plug in the values again. Velocity is equivalent to under root gm upon a.
Right.
And radius is equal to a root 3, so this will come out to be a square into 3. So the final solution would be 2 pi upon a cube into 3 gm. So this would be equivalent to the time period. So this is the solution for you. This is the velocity and this is the time period. So in such questions in which the diagram is complicated and a lot of things are happening, first we have to find the center of mass, because whenever there is circular motion happening in such a case, the circular motion is always about the center of mass. So first find the center of mass, then find the distance so that you have the radius of rotation, and then find the forces acting on it, and then use
So
these
basically, it
equations.
helps if you are thorough with the geometric principles also.
Yeah. First center, that is the prerequisite basically. If you don't know the geometric principles, then you won't be able to do anything. So this is the main equation that we use. F is equal to mv square upon r, and then the time period is equal to 2 pi upon omega.
Okay.
So this is it.
Now let's have a look at the fourth question. There are two hollow spheres, both of radius r. Their masses are m and 4m. So one sphere is of mass m, the other one is of 4m. They are placed at a distance of r. The gravitational field is 0 at point P at a distance x from mass m1. The gravitational potential at point P is V. Now you have to select correct options from the given options. And there can be more than one correct answers. So Arnav.
Okay, I'll first of all draw the diagram. It's a very simple thing. There's two spheres, two hollow spheres. One is of mass m,
Right.
and the other one is of mass 4m. Okay, so they are placed at a distance of r, and this point is at x. So over here the gravitational field is 0. So we have to find the point x, like it could be inside also, but if you think about it, the point can't be inside, because inside one shell the gravitational field due to this would be 0.
Correct.
And this would be non-zero, so obviously it has to be somewhere outside. So let us draw the coordinate axis.
But it could be at any side, right? Either between these two or to one side of m.
It can't be that way, because see, if the point is over here, then this thing would attract and this thing would also attract. So this is gravitational forces are always attractive, so it has to be in the center. It can't be on the end. So this is the only place where it can be. So fine. Now we begin. The gravitational field is equivalent to force upon m, which is equivalent to gm upon r square I cap. So first we'll find the gravitational field due to this spherical shell, and then we'll find it due to this. So the first one would be equivalent to gm upon x square I cap. I'm just writing these down, but in the exam you can like do it directly if you have a good feel of it or a good sense of the direction. A2 is equivalent to g into 4m upon r minus x square.
Right.
I cap. So this one will have a force in this direction, and this one will have it in this direction.
Right.
So both would cancel each other. So I'll directly write it down. Gm upon x square is equivalent to g into 4m upon r minus x whole square. Implies that most of the terms would cancel out.
Correct.
R minus x upon x is equivalent to 2. Under root of 4, 2. This can't be minus 2, because then x would come out to be negative. So use a little bit of common sense along. So with this, r upon x is equal to 3, and x is equivalent to r upon 3.
Right.
So first,
we found one correct answer.
Yeah, we have found one correct answer. So we have found the distance. Now we just have to find the gravitational potential.
Right.
So the gravitational potential is equivalent to minus gm upon r, where r is the distance from the center of the shell, and this is a scalar quantity. So the sign is not of any, like this denotes that the energy is negative, the potential is negative. So I'll just sum it up: minus g into m upon r upon 3 minus gm 4m, g into 4m into 2r upon 3. and this comes out to be minus 9 gm upon r. So this is the final answer. This is the x and this is the potential.
Correct. So the correct options would be
option number A and option number D.
right. So at the end of every question, you've been telling us what we learned from the question. What do you think is the key takeaway in this question?
The key takeaway in this question is that first of all, these are shells. Okay, so don't get perturbed and into thinking. Shells can be considered as point masses, and the point is outside. So don't go on into thinking, okay, what would happen if it was inside. And secondly, the forces and how to balance forces, how to find a point where the gravitational force is 0. This is the only thing. It's a pretty simple question. You should be able to do it if it comes in JEE.
Okay, let's move on to the next question, guys. Guys, the fifth question is, you're given the magnitude of the gravitational fields at distances r1 and r2 from the center of a uniform sphere of radius r and mass m, and these are f1 and f2 respectively. Now your job is to select correct options from the given 4 options, and remember there can be more than one correct answers here. Arnav?
Yep. See, first of all, I would advise you to read each and every option and then go about it. So this is a typical JEE question. They'll give you 4 options. They'll be lengthy. You might do a mistake under pressure and all. So just go on at go one option at a time, and you'll be good to go. See, first option is f1 upon f2, and r is equal to r1 upon r2, where r1 and r2 are inside the sphere. So for this, we know that first let's write the gravitational field due to a sphere. So the field, I'm writing f as field over here, is equal to g capital M upon r cube into r for r less than r, and this is equivalent to g m upon r square, where r is greater than r. So in the first option, the points are inside the sphere. So therefore, we'll use this formula. So the gravitational field f1 is equivalent to g m r1 upon r cube, and f2 is equal to gm r2 upon r cube. So f1 upon f2 is equal to r1 upon r2. Pretty straightforward. So the first option is correct. That is f1 upon f2 is equal to r1 upon r2. Fine. Now the second option, I'll read it down for you. R1 and R2 are outside the sphere. So in this case, the force would be equivalent to, field would be equivalent to gm upon r square. So f1 would be proportional to 1 upon r1 square, and f2 would be proportional to 1 upon r2 square. So therefore f1 upon f2 would be equivalent to r2 square upon r1 square. So this option is also correct, the second one. Fine. Now coming on to the third option. See, we know that the force, if the radius, if the point is inside the sphere, is proportional to r, and if it is outside, it is proportional to 1 upon r square. So therefore, you would say that f1 is over here in this question. It's a bit tricky. R1 is outside and r2 is inside. So r1 is outside. That is, f1 is outside. So f1 would be proportional to 1 upon r1 square, and f2 would be proportional to r. So therefore, f1 upon f2 would be equivalent to 1 upon r2 into r1 square. This is what you would say, but I would like to correct that. I would like to say that this is the incorrect option, because see, the constants are different. Over here there is a constant of r cube, so once you write f1, it would be gm upon r cube into f2 inside r2, and once you write this thing, it would be gm upon r1 square. So once you divide both of them, f1 upon f2 would be equivalent to r cube into r1 square into r2. So this constant will be there. So my advice to you is always check the constants. Don't do it this way. Okay, this is a very, very incorrect way of doing it. Always
unless the constants are same in both the cases.
You can't
don't directly take into consideration the proportionality.
And another thing to see is that this is dimensionally incorrect. This is a constant over here, so there should be a constant on this side also. So either you are quick enough to figure that out, or you do this. So and the fourth option, we'll have to check it. R2 is equivalent to so and so, and this thing R2 is outside, R1 is inside. So R2 is outside, so F2 would be gm upon R2 square, and F1 would be equivalent to gm upon r cube into r1. So therefore both the forces are equal. So gm upon r cube into r1 is equal to gm upon r2 square. So these would get cancelled off. So therefore r2 is equal to r cube upon r1 under root. So this is also the correct option.
So 3 correct options there.
Yep, A, B and D.
So guys, as Arnav mentioned earlier, when it comes to multiple choice questions, it's always the best option to go option by option.
Yeah. In a multiple correct, go for option A, then B, C, D. Do it slowly, take a little bit of time, but don't do it in a hurry. Because A people want you to, they know that you know the answer, but still they want you to do some silly mistake, such as this question. Over here in a hurry, you might just mark this as correct.
Correct. So guys, let's move on to the next question now.